At logs today, I have a really, really easy way for you to remember how to convert a log into an exponential function and back and forth. And you guys are going to think I'm crazy for a second, but bear with me. Logs are my bae.
Okay.
Julia!
Because watch. Because watch.
Yes.
Logs are my bae. I love logs. They're awesome.
I was like copying it down.
No, you really write it down, because watch. And if you look at a log in order, the first thing you're going to see is the base. The next thing you see is the answer. And then the thing on the other side of the equal sign is the exponent.
Yeah, how you feel?
I know what she was gonna do, but I mean.
So logs are my base. So you can literally take anything that's a log and you can reposition it to look from the log that's on the left to look like this equation on the right, which we're more used to. We're more used to seeing an equation and trying to find the exponent than trying to look at a log. So we're just repositioning stuff. The base goes here, the exponent goes on the base, and the answer goes to the other side. So that's what we're practicing in these first couple of problems, is repositioning everything from the log form into the exponential form. So the first thing you start with is the base. Looking, it says base, answer, exponent. So looking at number 1, the base we start with first, but it's a little 7 in a log. You're going to turn it into a big 7 when you do your exponential function. And then next should come the exponent, B-A-E. 3 is going to be the exponent, and x is the answer that goes on the other side. We're just rewriting this right now, and that's how your homework's going to start too. You're just rewriting it. So then if you look at number 2, you got to start with the base. What's the base? You're not solving anything yet. Base, answer, exponent. Little b is going to turn into your base, so now it's a big B. The exponent, 2, 25 is the answer. Try number 3, take a minute. You're just repositioning. So if you look at number 3, what are you going to start with? 4 is your base. Which one's the exponent? No, this is B-A-E, so the exponent is y. The answer is 26. Okay? So now we're going the other way for the next section. Is they're giving you the exponent, you need to write what the log equation would look like here.
So 2 is like kind of saying Edla.
So you're going to start with the word log.
Maybe log.
Log, your base goes first. It goes base, answer, exponent. So this actually should be easier. You just have to put them in the right spot. Base is 2. That 2 now becomes a subscript with a log. We always put the base for a log as a subscript. It's like an exponent, but instead of being high, it's low. So it should be a tinier 2, lower. Then we put the answer. The answer right now is, what's the answer to this equation? X equal to the exponent, 5. Base, answer, exponent. The x and the 5 should be on the same line as the log, but the 2 drops. The 2 is a subscript. So when we look at number 2, it's going to be log. What's going to be my subscript? Log base b of the answer, 27, equals the exponent, 3. Try number 3.
Okay.
So this should be log base e
33.
of 33 is going to equal y. Questions? The next thing we're going to do is we're evaluating a log. We now want to know what is the answer to this problem. So the first thing you can do in number 1 is you can set it equal to x.
What was that fancy stuff? What was that? What was that color wheel?
That's how they do colors on here. So if you set it equal to x, we're first going to rewrite this in exponential form, because I think for the first couple you guys are going to understand it more if we rewrite it in exponential form. So we rewrite it as the base is 2, the exponent, x has to equal the answer 32. Now you just have to tell me what x is. That's the difference here, is you're actually telling me what the answer is. 2 to what power equals 32? X would equal 5, right? 2 to the 5th power is how you get 32? You have to think, how many times do I multiply 2 to get to 32? If you need to count on your fingers, count it out on your fingers. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. I got to 5. 2, you got to multiply by 2. 2, 4, 8, 16, 32. It's a power, so you're multiplying a bunch of 2's together. So when you look at number 2, what we're really thinking here, when we look at this problem, we're looking at that 3. I'm asking myself what power, because we're going to see more and more of these over the next couple days, what power do I raise 3 to, I can't write on here as well, to get 81. 3 to what power gets me 81? What power am I raising 3 to bring it up to that 81? 3 times 3 times 3 is 27. 3 times 3 is 9. Times another 3 is 27. Times another 3 is 81. So you need 4. You got to understand those two, or the next two become even more complicated. Because the next one, the base is 36 to the x power has to equal 6. 36 to some power has to end up equaling 6.
Negative something.
So the question is, and I'm going to write a couple notes up here. Couple review things. How do I make 36 to 6 in general? Wouldn't it be the square root? So what power is the square root?
Negative.
Square root is the same as taking it to what power? Not the negative power. The 1/2 power, right? 1/2? What would the cube root be? Cube root would be 1/3. Fourth root would be 1/4. So you just need to know those. I think mostly you're going to see square root and cube root, but that's what power it is. So the answer then, if it's a square root, to get from here to here, I have to take the square root. The power that I need to do to take the square root is 1/2. The answer is, what power are you taking that to? The power is 1/2. So if you see it's a square root, that power is 1/2. You have to make sure you're writing the power down, because that's what x is. Did I say power enough? No? All right, the last one. 5 to what power equals 1/25?
Wait, nobody said the answer. I didn't hear it. Wait.
I wrote it out. I wrote it down. So my question is, how do you get the x to move to, how do you get something to move to the bottom? What power does that mean?
-2.
To get it to move to the power, it has to have a to the bottom, it has to have a negative power, right? So first off, the first thing I would do is I would think of, how do I make 25? 5 to what power is 25? 5 squared is 25, so I need a 2 there, but because it's on the bottom, the 2 has to be negative. So this is x equals -2. You're still thinking multiply, Amari. You need to think of a power. What degree am I taking it to? What exponent am I going to put there? You're trying to multiply 5 times 5 is 25. That's not what we want to know. 5 to what power? How many 5s do you need to get to 25? I need 2 5s, so the power is 2. How do you get from 36 to 6? You take the square root, right? The square root is the 1/2 power. You have to tell me what power the square root is. The square root is the 1/2 power. Yes. Can I write 2 more down here? How about that?
My foot went numb. Oh.
Log base 8 of 2 and log base 3 1/27. Can we try those two? Try those two. You can't divide, guys. You can't divide, you can't multiply. You have to think of a power. So you need to think of, if you can't think of a power because it's getting smaller, you need to think of a root. What root would you do to 8? It's the cubic root. The cubic root means, what did I just tell you? I wrote it at the top. It means the 1/3 power.
So it's 1/3.
So we take the cube root of it, and we get 8 to the 1/3 power equals 2. So x, what we're trying to find is the power. X is 1/3, isn't it? When you look at the second one, how do I get 3 to be 27? That's what I would think in my head here first.
So it's negative
3 to what power is 27? 3 to the 3rd power is 27, right? And then because it's on the bottom, the only thing that's going to make it move to the bottom is making it negative, right?
So negative what?
Negative 3? Ooh. Alright, the next 2 things hopefully should make some sense here. The first property, these are 2 just very basic properties that have to do with zeros and ones here. This says b to what power equals b.
B to the first power?
Doesn't it make sense that b to the first power would equal b? So anytime these are the same, if the base and the part next to it are the same, you're going to get 1. That's the only power you can raise it to keep it the same. If it stays the same, that's going to be the first power. The other problem here says b to what power equals 1. If you have, if you know that you have to raise it to a power and get 1, what power makes it 1? 0. So that's the thinking you can go through if you rewrite it as an exponent. But it should get to the point that you see something like this and you're like, well, this is staying the same, so the power I raised this to get 9 is just 1. The power I raise 8 to make it 1 is 0. Does that make sense? 9 to the first power is how I get 9. 8 to the 0 power is how I get 1. You're telling me what power is the answer. The answer has to do with the exponent. When you're doing a log, the answer is the exponent. What power do I raise x to get x? 1, right? X to the first power is how I get x, isn't it?
Did we write these